Okay, let's have a look at one of the most unpopular, most difficult PAT questions of all time. This was 2018, question 18. If you haven't had a go at this question before, feel free to give it a go. I'm going to take it slow and not just show you how to do the question, because that's a bit useless. You can get that anywhere. I'm going to try and show you how you could know what to do if you come across a question as weird as this. So there's a couple of things in here that unfortunately you need to know that aren't really covered at A level very explicitly. So I'm just going to mention them before we start. What does this mean? Because, I mean, obviously you can sort of understand what they're roughly getting at, but how are you actually supposed to use that to help you? Well, what this actually means is that delta x is a distance much, much less than L or x. And so what that allows us to do, whenever you see something like this should immediately be a trigger point for what we call first order approximations. And these are actually, this is less easy than it may sound. Effectively, what you need to know with this is, the way I think of this is that delta x is much, much less than L. That means that delta x over L is much, much less than 1. And same thing for delta x over x. But that does not mean that you can just get rid of anything that's delta x over L, because then you just won't have any delta x's in your answer. And as you can see, that you need a delta x in your answer. So whenever you see this much, much less than thing, what does that mean? Well, what you should be aiming to do is get it into this form, sort of delta x over L. And let's say we had something like this. Okay, in our answer. What this first order approximation allows us to do when they tell us this is you want to keep every single term that's up to and including delta x over L. But anything bigger than that, e.g. delta x squared over L squared, you can just get rid of. So this we would rewrite out as, if you expanded it out, you'd get 1 plus 5 delta x over L plus, what is it? Is it 10? Something like 10. It doesn't really matter because we're about to get rid of it anyway. And what this first order approximation means is, once you have it in this form, you want to keep these. You never want to get rid of the first orders, but you want to just get rid of any higher order terms. Now, why are we allowed to do this? Well, if delta x over L is much, much less than 1, e.g. about 0.01, well, that might be important in an answer. But then any higher order terms, 0.01 squared, for example, well, that's 0.001. And so, wait, yeah, am I wrong? I'm wrong, I think. Oh, God. I think that's right. Point being, it's much, much smaller and therefore irrelevant. So that's what you need to know for this question. That may have acted as, I think that might have acted as a roadblock to this question, but it's still very confusing and very difficult, much harder than most PAT questions are. So that's something you need to be aware of, and I'm going to assume that knowledge going through this question. So I think the big difference in this PAT question compared to most of them is the lack of guidance. They give you this diagram, and then all of a sudden, they throw you straight in and say, find this, show this. And that looks like it just comes out of nowhere completely. So this is where the question approach I teach comes in. Now, what do you want to do? Well, first of all, what you don't want to do is skip this question, because there's 7 marks and then 2 marks. So that's 9 marks. Now, I don't believe in skipping questions in the PAT. What I will say is that obviously you don't need to solve every question, but even in questions you can't solve, for example, a 7 marker here, you should never be getting 0 out of 7, because the first few marks are usually extremely easy. And what do I mean by that? Well, what we're going to do is we're going to say, okay, we want to find this horrible thing. I don't really care. Now, why don't I care? Well, because before I even start thinking about getting that, I have got a lot to do. And it's a lot of easy stuff that you will know. So let's have a look at what I mean by that. So, okay, what can we start by doing? Well, this is clearly a mechanics problem. And in mechanics problems, what you need to do is start labeling on forces. So let's start off by saying, okay, that is T. I'm only going to label on one of them because the forces will be identical. So that's T. The length of this string is L. Now, that's very important. It's important to notice that they've given that to you, okay? Because they'll have given it to you for a reason. The distance between these two things, well, it was X, and now it's decreased by that delta X. So in other words, the distance between the centers was X. Now let's be very careful. I believe it's now X minus 2 delta X. The distance between the centers. Notice how none of this is particularly taxing to label on. We can just label these on. What else we got? Well, we've definitely got mg down. Okay. What else can we label on? Why are they like that? Well, it must be gravity pulling them together, by which gravitational force Fg will blah, 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 blah. So in other words, we've also got Fg going that way. Okay. And what is Fg? Well, we know what Fg is, so we can write that down for another easy mark. Fg must be capital G times m squared, GMM, over the distance between the centers squared. So X minus 2 delta X squared. Okay. What else can we do? Well, all of this is very standard, hopefully. And just notice that this, I really don't care about that yet. We'll care about it later, obviously, but it really doesn't matter, because in a mechanics question, what can you do? Well, it's always going to be this, regardless of how you get to the end question, the end result. You're always going to have to do this. So just do this first, and you'll get 3 out of 7 marks already. So now, what else is obvious to do? Well, what else do we do in mechanics questions that are in equilibrium? Well, we definitely start resolving. So upwards, we're going to have T, this should be easier for me. T cos theta. I'm going to write that as TC. And then this way is going to be T sine theta. Okay. And so now we've got Fg as that. What else do we have immediately? Well, we've got that Tc, they're in equilibrium, so Tc must be equal to mg. Fine, that's nice. And Ts must be equal to Fg. And in fact, we can, well, let's just leave it like that for the moment. Okay. And so we've done all the really obvious stuff now. So now and only now am I going to start looking at this answer. And what do I mean when I say looking at this answer? Well, what I'm going to say to myself is, first of all, do I have everything I need in order to solve this question? So let's have a look. We need a delta x. Have we got that? Yes. We need an x. We got that? Yes. We need a g, an m, an x, and a g. So we've got all of that. But we also need an L. We don't have an L in any of our equations. So we better get a fourth equation before even worrying about starting to work towards the answer, because otherwise there's no way we're going to get there. And so just looking at this diagram, how are we going to get an L? Well, the only thing we can say, L is just a sort of a distance. So the only option we have is sort of some geometrical arguments. So if we sort of look at this diagram, we've got that side is L, that side is dx, and that is theta. So the only way we're getting an L in there is by saying that that's the opposite and the hypotenuse. So L sine theta equals dx. Okay, so we've got that equation. Right, so now we've done the first step in terms of, now we have everything we need in order to solve the question in theory. So now I look at my equations and ask, okay, so what do we want to keep? Well, we want to keep dx, we want to keep x, and when I say keep, I'm just saying what's appearing in the answer. Notice how I'm not worried about how we're going to get there. I'm just looking at their answer and just saying, well, what structure does it have? What do I want to keep? You know, so that I have some hope of getting there eventually. And what don't I have to worry about? I don't have to worry about getting rid of L. I can keep M. I can keep G. And that's everything. Okay. And so that means, well, with my things, what do I have to get rid of in order to have an answer in the same form as them? Well, it's anything to do with theta. They don't have any thetas in there. They don't have any T's. And they don't have any FGs. I think that's everything that's that we don't want. Okay, and so now I'm going to make the claim that, and this is literally how you do, or how I personally do, and I think it's a nice, easy way of doing it, how you approach any question that's got to show that answer that just comes out of, seems to come out of nowhere and looks extremely intimidating. All you want to do is do the normal stuff first, check what you want to have in your answer, make sure you've got, you know, use what showed up in the answer to get all the equations you want. So for example, we knew we needed an L, so we got that fourth equation, and then just say, okay, well, what's in the answer that I can keep? Well, that means you don't need to get rid of any of these things, but then anything that's left over, you had better get rid of them. And so now it's just an exercise in eliminating those. So let's just get rid of FG. And how do we do that? Well, we just set, so I'll give these all names. I'll say that's 1, that's 2, that's 3, that's 4. So let's start by just saying, okay, well, 4, we can just say that that is sine theta equals dx. Okay. And we can say that using 1 and 3, so 1 equals 3, we've got ts sine theta equals gm squared over x minus 2 delta x squared. Okay, and we can do better than that because we know we don't want sine theta, so we can get rid of that sine theta and call it dx over L. So let's just do that. T delta x over L. And I really want to emphasize, I know I'm going quite slowly, but I want to emphasize that I'm still not worrying about getting into this form in particular. I'm just worried about getting the right sort of letters, and the form itself will happen automatically. So, okay, we've done that. Well, now we need to get rid of t, because we've got rid of fg and theta. So t is going to be, well, using 2, we've got that t equals mg over c. And so plugging that in, we've got mg dx over L cos theta equals gm squared over x minus 2 delta x squared. Okay, now we've got a bit of a problem. And what is that problem? Well, we've got a cos theta there, and we need to think about how we're going to get rid of cos theta. So, in other words, how are we going to do this? This is where we're going to have to start using this idea that the lengths are small and so the angles are small. So this is a small angle. And so what can we say? Well, we can say that theta, sine theta is roughly equal to theta. So theta is roughly equal to delta x over L. Okay, and cos theta, well, theta is small, so cos theta is roughly equal to 1 minus theta squared over 2. But if theta is dx over L, then cos theta is roughly equal to 1 minus delta x over L squared over 2. And if you were paying attention earlier, hopefully you'll immediately be very happy to see this delta x over L squared, because what we can say then is that cos theta is roughly equal to 1. because delta x over L squared is not something we keep. So, okay, so that means that cos theta is just 1. And it's important to notice that you can't just assume immediately that cos theta is 1. You want to do that, firstly, because there'll be a mark involved, and secondly, because in certain situations, you might get just a delta, like, for example, the square root of cos theta might, no, that's not a good example, but you might have somehow, for example, if it was cos theta to the half, well, you might end up with a delta x over L term rather than a delta x over L squared term. So just be aware of this is how you want to deal with small angles. Okay, so we've got, just by playing that game and eliminating everything we didn't want in a clear way, we've got that mg delta x over L is equal to gm squared over x minus 2 delta x squared. Okay, that now looks like we've just got exactly what we want in our equation. The same variables. So now all we've got left to do, we've done the hard bit, all we've got left to do is say, well, what do we want to, what form have they given? Well, they've just rearranged for delta x. Okay, so let's have a look at how we're going to do that. Well, fine. So the first thing to notice is that the delta x is trapped in here are going to be a bit irritating. We need delta x on its own on the left. It doesn't appear on the right. So let's rearrange this by saying that this is x minus 2 delta x squared is equal to g m L over delta x, I believe. Okay, and we want to get rid of as many delta x as we can. And if you remember what I said, you can't just get rid of delta x. You don't want to just get rid of delta x or delta x squared. What you do want to get rid of is delta x over x squared, for example, because that is very small. And so what I'm going to do is I'm going to take out an x from this bracket, and that becomes, so it becomes x squared 1 minus 2 delta x over x squared equals gm L over delta x. Okay, and so expanding that out, we get that x squared 1 minus 4 delta x over x. We have to keep that, but then plus 4 delta x squared over x squared just goes away. So we can say that that's roughly equal to gm L over delta x. Okay, that's looking a lot better. So if we expand that out, we've got x squared minus 4x delta x times by delta x equals gm L. Now, this is important. This is why I said you don't just get rid of delta x squared. You don't just kill that, because that's not allowed. You can only get rid of delta x over x squared or delta x over L squared. So here we have, and this is clearly important for this question, we've now got this. I'm going to do a bit of rearranging. So I'm going to say that this is, in fact, no, I'm going to expand it out, divide through by x. So we get x delta x minus 4 delta x squared equals gml over x. Then I'm going to flip the signs, so we get and divide by 4. So we're going to get delta x squared minus x over 4 delta x equals minus gml over 4x. Okay, and so now, because we're not allowed to get rid of delta x squared, even though it's very tempting, yet we want just delta x on its own. So what we need to do is simply, well, it's effectively, we just want to make delta x, get delta x on its own. So we need to get rid of that linear term. In other words, we just need to effectively complete the square on delta x, because that's how you get rid of linear terms. So if we just write this as delta x minus x over 8 all squared minus x over 8 squared is equal to minus GML over 4x. Then we have finally delta x minus x over 8 squared equals x over 8 squared minus GML over 4x. And so square rooting, bringing across the x over 8, we get delta x is roughly equal to x over 8 plus or minus the square root of x over 8 squared minus GML over 4x. And so having a look at their answer, well, I believe I've dropped the G at some point. That's not very important. Where's it gone? I've literally just forgotten it. Where did it go? Yeah, it should have been here from the start. So that can go there, that can go there. There. Okay, so now it's exactly in the form of their answer, except we've got plus or minus, and they've just got minus. So now you just need to make an argument to get the last mark. Well, why is it minus? Well, if it was a plus, then what we would be saying is delta x is roughly equal to x over 8 plus something that's roughly the size, plus roughly x over 8. So in other words, but we know delta x is much, much less than x. So that can't be true. So it must be the minus sign, because that's the only way of getting a very small value of delta x. So you'd want to write an argument to that effect to make sure you get the mark for it. But then we arrive at our answer. Now, that was, as far as PAT questions go, that was extremely difficult and also very stingy for 7 marks, to be honest. But hopefully that method sort of shows how you can, it really doesn't matter what they're asking you for in a PAT question. All you want to do is sort of identify what type of question it is, in this case, equilibrium sort of mechanics, and just start off by writing out the obvious stuff, the normal stuff, and then just turns it into sort of a little game of algebra where you figure out what you want to keep, what you want to get rid of, and it sort of just works out.